Hey guys, welcome to the 1.3 flipped lesson on segments and their measures. Before we get started, let's talk about the difference between a postulate versus a theorem. A postulate is a rule that is accepted without proof. It's something that's kind of intuitive and it makes sense, so we just accept it as truth. Where a theorem is a rule that has been proven true formally. Now, we're going to talk more about proving things formally, but we're not quite there yet in the school year. Points that lie on a line can be matched one-to-one with real numbers. The real number that corresponds to a point is the coordinate of that point. So let's take a look at an example that we see here. We have point A and point B. The coordinate of point A is -6. And the coordinate for point B is +2. Now, we can use these coordinates to find the distance in between 2 points. The ruler postulate states that the distance between 2 points is the absolute value of the difference between the coordinates. So, if I wanted to find the length of segment AB, I would take the absolute value of the difference between these coordinates. Now this is giving me -8. Let's think about why the absolute value is a part of this postulate. If we're referring to distance, distance is never going to be negative. It's always going to be represented as a positive unit. That's why we have these absolute value bars inside this equation. Therefore, segment AB has a length of 8 units. This brings me to a very important point about mathematical notation. Sometimes we're going to refer to the segment without a bar, and when the bar is not included, we're talking about the length. When the bar is included, we're referring to the segment in general. So let's take a look at this example. Notice we have coordinate A, or point A is at coordinate 3. Point B is at coordinate 5.5. So if I wanted to find the length of AB, I'm going to take the absolute value of the difference of these coordinates. Therefore, if we take the absolute value of -2.5, we get +2.5 units. So if you were to read this statement out loud, you would read it as the length of AB is 2.5 units. Now let's talk about a concept referred to as betweenness. When 3 points lie on a line, you can say that one of them is between the other 2. So as you guys see in the top example, A, B, and C are collinear. Therefore, we can state that B is between points A and C. Now notice that D, E, and F are not collinear. Therefore, we cannot state that E is between points D and F. Understanding this is going to allow us to communicate a lot more easily throughout the year. If the distance from Athens to Macon is 80 miles, and the distance from Macon to Albany is 90 miles, then what's the distance from Athens to Albany? Hopefully you're able to quickly identify that this would be 170 miles. Now, this seems very intuitive and easy to make sense of, but what you just used was the segment addition postulate in your head. You said that from Athens to Macon is 80 miles, and we're going to add that to the distance from Macon to Albany, which is 90 miles. This gives us a distance from Athens to Albany, which you concluded was 170 miles. postulate says. Now notice it has to be between the two other points that we're considering in order for this postulate to hold. Let's take a look at another example and illustrate this a few additional ways. If I wanted to find the length of PR, I could represent that as PQ plus QR. I could also add more than two segments together. So if I wanted to find the length of PS, I would take the length of PQ plus the length of QR plus the length of RS. So here's just a few more examples illustrating this postulate. The next thing we're going to talk about is Pythagorean theorem and distance formula. Before I get to what the distance formula is, let's remind ourselves of Pythagorean theorem. So this is probably something that you might remember from Algebra 1. But Pythagorean theorem states that a squared plus b squared equals c squared. This allows us to find missing side lengths of a right triangle. Right now, we don't see a right triangle, but I could sketch this picture to include a right triangle. So, we can easily identify the horizontal and vertical lengths. So let's do that first. If I want to find this horizontal length, I'm going to have to take one of my x-coordinates minus my other x-coordinate, and remember, we're going to use the absolute value because distance is always positive. So in this case, I have negative 680 minus 1020. This tells us that the length is 1,700, and we don't know the units on this one. All right, but here is that horizontal distance. Now let's talk about the vertical distance. If I wanted to find the length of this vertical segment, I'm going to take y minus y, and don't forget, I'm going to use the absolute value bars because distance is always positive. Well, this is equal to 960 minus a negative 480. Keep in mind, if you subtracted negative, it's really addition. So this is going to give us a length of 1,440 units. So, knowing the horizontal and vertical length is going to allow us to find the diagonal length by plugging this into Pythagorean theorem. So, we have a squared plus b squared equals c squared. C squared is our diagonal distance, which is our unknown value. Using our calculator, we can then figure out that 1,700 squared plus 1,440 squared gives us 496,360. Our last step in solving for C is to take the square root of both sides. Using our calculator, we find that this is approximately 2,227 units long. Now, the reason why I started with Pythagorean theorem is because the distance formula is derived from Pythagorean theorem. That means the distance formula comes from Pythagorean theorem. Let's take a look at the distance formula. The distance formula allows us to find the distance in between any two coordinates. So let's repeat this process of finding the length of segment AB, okay, but using the distance formula instead. Notice that to find the length of AB, we're going to take the square root of the difference of the x's squared plus the difference of the y's want you to notice now, and I'm going to highlight it for us, is the relationship between this piece and this piece. Notice that those statements are almost identical, but on this side, we see that the square root has already been taken instead of saving it for the last step. So, if we finish out this process, we see that the length of AB is approximately 2,227 units. Hopefully this highlights the relationship between Pythagorean theorem and distance formula. Make sure you jot this down in your notes before moving forward. All right, the last thing we're going to end with is just a little bit of practice. We're going to see if there are any segments that are congruent in this picture by using distance formula. So let's start with finding the length of segment AC. To do that, we're going to take the square root of x minus x squared. Remember, when you subtract a negative, it becomes positive, plus y minus y squared. If we simplify, we should get 4 squared plus 1 squared, which is 16 plus 1. Therefore, we can conclude that the length of AC is equal to the square root of 17. Let's move on to AB. If I want to find the distance between coordinates A and B, I'm going to take the square root of x minus x. Remember, if you subtract a negative, it becomes positive. Then y minus y squared. That will give us negative 3 squared plus 2 squared, which is negative 3 times negative 3 is 9. 2 times 2 is 4. So it looks like the length of AB is the square root of 13. The last length we're going to find is the length of AD. To do that, we're going to take the square root of x minus x, so 2 minus a negative 1 squared, plus y minus y, negative 1 minus 1 squared. As we simplify, we get 3 squared plus negative 2 squared, which gives us 9 plus 4. So AD has a length of the square root of 13. Now, the last thing I'm going to emphasize is that mathematical notation. Remember, if I'm referring to lengths being equal, then I could say in this example, the length of AB is equal to the length of AD. This means that those segments are congruent. So if I'm talking about them being congruent, I'm just referring to the segments in general, then I would include the bar. So segment AB is congruent to segment AD. Just remember that when you're referring to lengths, you are